Hello there, and welcome back. What we're going to do is take the graph of y equals f of x and use it to sketch the graph of its derivative. Now remember, the derivative of f of x is really the slope of the tangent line at a value of x. So what we're basically doing is examining how the slopes of the tangent lines change as x changes. So in order to get a sense of what's happening here, I'm just going to choose x equals 0 here, and then we're going to change in both directions to see what our slopes are doing. So at x equals 0, notice that the slope is positive. It's not a very large positive number from what it looks like. We don't know the scale of the function, and that's okay, because all we're doing is looking at what happens as we change. So as we go to the right, x increasing, notice that the slopes are changing pretty sharply. Here's a slope that's, larger than the first one, even larger than the second one, and even larger and larger and larger. So that means the values of those slopes are what I'm going to plot here. So starting at x equals 0, I'm going to say that that is the slope. And then we're increasing quite sharply. So very similar to the actual function. We'll talk about that in a moment. And then as if we choose values of negative values of x, well, let's see what's happening. As x goes to the left, those slopes are still positive, but they're getting closer and closer to 0. So that means as x goes to the left, my derivative graph is also going to basically hug the x-axis. It's going to be a horizontal asymptote there. So, and I didn't really do a good job of making it very close to the x-axis. Let me try that again. There, that's better. So there's the graph of our derivative, and notice it looks very similar to the graph of f. And the graph of f really reminds me of an exponential function. And as we know, let's just say it's e to the x. We know the derivative of e to the x is again e to the x, so it looks very similar to its original function. So at least we have that link to go back to too. But again, to graph a derivative, we look for things like how do the slopes change? And as you go to the right, they're changing sharply. They're going way up. The slopes are going way up, I should say, which means that the derivative increases pretty sharply. And as we go to the left, my slopes are getting closer to 0, which means my derivative graph is getting close to 0 as x moves to the left. So there we have sketching the graph of a derivative.